Okay, hello everyone. Today's topic is about the expanding universe. Okay, so let's move to the first part about expanding universe. So before knowing about whether the universe is expanding or like shrinking, we have to know the Doppler effect. Okay, so what is Doppler effect? You can find in this figure. I give you example like an ambulance is moving towards to the people B and is moving like backward from people A. Okay, so here you can find the bell on the ambulance just like release waves, right? Maybe sound waves and maybe the radiation. And you will find that the bee will receive the sound or like the radiation, right? And you will find the waves is just from the point and to release a ripple waves, okay, like this way. So you can find when the ambulance is closer to B, and you can find the distance between each ripple is very small, right? Okay. So we can say, oh, between each ripples, they have a very small distance. That means they're closer and closer. So ambulance and the people B are just like have a closer distance, and they have maybe they can find B can receive a higher frequency waves right here, right? And for people A, you're going to find that their distance between the two adjacent ripple is very closer, and you'll find that the frequency is very low. Okay, so here you can find frequency at A is very low and frequency at B is very high. That means if a wave is moving toward you, okay, and it's moving closer to you, and you find the frequency becomes higher and the frequency becomes lower when the wave is moving away from you. Okay. So also you can find in our daily life, like you are taking a train to other city, and you will find when the train just arriving into the station, and you will release a sound, right? Like boo boo, like this sound, right? And you will find that when the train just have a boo boo sound, you will find, oh, maybe here when the train is very far away from you, you will find the sound is have a very like a low frequency, and you will find, oh, maybe the sound is very tiny. Maybe after like closing or arriving to you, you'll find the sound becomes sharper and it becomes a higher frequency. Okay, that becomes that. Oh, maybe when closer to you has a sharper frequency with time taking increase, and when you're leaving with you, you'll find the frequency decreases. Okay. So here you are find that there's an example, and using the Doppler effect, we knew that when an object moving closer to you, the frequency will increase, and moving away from you, the frequency will decrease. Okay. So for the radiation, we said, oh, if an object is moving toward you, the frequency of the radiation will increase. Okay. So if here is a yellow star, and you will find that maybe it will turn its color to blue because blue has a smaller wavelength of the like maybe we have velocity c equals to frequency times wavelength, right? Because blue has a smaller wavelength rather than the yellow star. Okay, so here it has a bigger frequency than the yellow star or than the original star. Okay, so if you observe a blue or like a color turns blue, a colorful star turns blue, that means the star is moving toward you. Okay, and you'll find the frequency becomes higher, and it just turns the color from the yellow to the blue. Okay. And you'll find that if there is a star changes color into red, we'll find, oh, maybe here the frequency decreases because for red, it has a smaller frequency to compare with the yellow. Okay. So we can call this redshift and blueshift, and this can help me to determine whether the star is moving closer to us or moving away from us. Okay, so this is just using Doppler effect in the radiation, the same meaning and the same principle. Okay, this is for redshift. And also you'll find that, like here, I give you another example, like a star that's moving towards your person, and you'll find there's a blue shift because frequency of the wave is very small. So here you'll find, oh, very high. Okay, so we'll find, oh, maybe here the star turns into blue, and here the star received by the human on the left maybe turns to be red. Okay. And in fact, scientists has do many experiments like here. They just draw the spectrum and observe from the stars, and they just receive the radiation from reflected by the star every year. Okay, and they find that maybe this is the radiation they first released, and this is the spectrum they like accepted like reflected by the star. Okay, and you will find each lines or each black lines in the graph just like moving to the left or moving to the red part, right? So we knew that the red lines or like red rays, they have a stronger or bigger wavelength, but they have a smaller frequency, right? So we can find that the frequency is decreasing for the stars. Okay. So we can call this the frequency decreases means they're just moving away from us, okay? So this also make an evidence why the universe is expanding, okay? That is because the frequency is just increasing with the time taken. Oh, sorry, decreasing with the time taken, time passing by, okay? So scientists just draw the graph, like they're just make a statistics on the redshift and the distance, and you find that maybe the distance is bigger, and you'll find that the redshift is also has a bigger phenomenon in this graph, okay? The distance increase, redshift will also increase, or the like universe expanding the faster, become more and more faster and moving away from us, okay? So why has this? Okay, so maybe we can use Big Bang theory to explain this. So for Big Bang, we knew that Big Bang means explosion, right? So for the explosion, we can set, oh, maybe here there's a very big explosion, and we can set like just a firecracker and it explode. So it means that, oh, maybe here it just has to become different pieces. Like here's a firecracker, okay, and it be broken into pieces like here. So just moving to different direction, like here, you're just like separating to different parts. Okay. So we can say, oh, for Big Bang theory, just explained why the universe from point to different pieces and why the universe is expanding at this period. Okay. Because the universe always surrounded by the vacuum, so there's no friction force. So for every pieces, they can just moving like to different direction and they're moving at different speed. Okay. So maybe in IGCSE you don't need to know further about this, but maybe in the future, if you're just very interested about astronomy, you will know that they have a very strange physical phenomenon that each piece is just moving to their direction, and you'll find that their velocity is increasing with the time taken increase. Okay. So this is a very weird, but in IGCSE we just knew or make a basic understanding of this. Okay, just know that this is because Big Bang that Big Bang makes every pieces or every part of the universe expanding from the center. Okay, so you can say that is Big Bang. Okay. Okay, so here we can find that maybe for several billion of years, and you can find the universe just a point or a dot. Okay, it has a very high density and it contains all the mass in it. Okay, and finally it has a Big Bang, and you will find that oh maybe every part of the like here, just like a firecracker, just moving to different direction, and they become further with each other. They have a further distance with each other, and you can find they're just expanding all the time. Okay. So till now, you can find maybe some planet you are just observed from the other system, like we have solar system, maybe a alpha system and beta system. They're just moving away from us. Okay. But that is for the Big Bang theory and some conclusion for this. Okay, so for this lesson, you have to know that there has a redshift, and redshift means that the universe explode. Okay, so maybe for many years ago, the universe is just a dot. So after the explosion, just like moving from different direction. That means they're just or all the parts of the universe just moving far away from the center with the time taking increase. Okay. So this is for today's lesson. Let's see you next day. Bye.